Welcome to this very quick video on cells and more particularly hydrogen fuel cells, but we'll get to that in a minute. So what is a cell? Well, a cell is one electrode and another electrode, two electrodes connected by a wire. Okay, let's have a light bulb in the middle. Okay, and they're dipping in some sort of electrolyte, some sort of liquid. That's not a very nice one, is it? But that'll do. All right. So let's have a think here. Let's call this one zinc and this one copper. And let's have a solution of sulfuric acid here. Okay. Now, as you all probably know, the more reactive metal will lose its electrons and they'll go through the light bulb and go to the less reactive metal and powering the light bulb. All right. A movement of electrons. These are electrons moving around, and they always go from the more reactive to the less reactive side. Okay. All right. Now, there you go. I think that's about it, really. As this goes on, the zinc goes into solution, so this gets worn away. Okay, and hydrogen gas is evolved at the copper side there. But the whole point is electrons go through some sort of device, and it powers the device. Powers the device. Okay. All right. So that's that. Very simple. All right. So let's get rid of all this. Oh no, let's just move up the page a little bit. So what's a fuel cell then? Well, a fuel cell is something very similar, but we use hydrogen gas. Goes in one end. Hydrogen goes in one end, and there is the hydrogen container. Okay. Now there's the oxygen container at the other side. Oxygen, and this one is hydrogen. Okay, there's some sort of fluid between the two. I'll talk about that in a minute. All right. There's often a catalyst somewhere around. Okay, and one side is connected to another, and there's our light bulb. Okay, this is roughly, it's not a very good picture, but it's roughly it. So let's try and, can I make a nice, oh, I can't. Okay, I want to redraw that and say my hydrogen goes in here, and there's a hole there. There goes my hydrogen. And here, where my oxygen goes in and the water goes out. Water's a byproduct. It's not a very nice picture, is it? But hydrogen goes in one side, oxygen goes in the other side. Okay? And the middle, there's often, this is an electrolyte. All right, and the electrolyte is often sodium hydroxide solution. All right. Now, it's exactly the same principle as the other cell we looked at just a second ago. The hydrogen here is H2. Okay, it reacts and forms protons. Okay, now what's the reaction there then? Let's have a look. It's this. It starts off as H2 and it forms 2H plus 2 electrons. So the hydrogen, loses protons. Sorry, hydrogen loses electrons, and the electrons build up and they flow through here. Okay, so these are electrons. Okay, there. All right, when they get to this side, the oxygen grabs the electrons. Okay, and what does it form? Let's have a look at what that forms. Let's try a different color, this color here. Okay, so the oxygen grabs the electrons down here, all right, and it reacts with the electrons and water. Okay, and it forms hydroxide ions. I think that's balanced, is that? 1, 2, 3. Oh, there's two of those. Okay, so the oxygen here reacts with these electrons coming in and it forms hydroxide ions. All right, so one side produces protons, okay, or hydrogen ions, we should say, really. Hydrogen ions, and the other side produces these hydroxide ions. Okay, why does this happen like this? Well, the hydrogen loses its electrons, produces hydrogen ions, okay, and the electrons flow through the external circuit, and if this was a light bulb, it would make the light bulb go on, okay, and then they come down here, and the electrons react with the oxygen, okay, all right, to form hydroxide ions. Now, at this surface here, okay, the hydroxide ions form here. There's one forming there, okay, and the hydroxide ions themselves are going to react with the hydrogen ions. So hydroxide ions from the left-hand side are going to meet the hydroxide ions from the right-hand side, and they're going to form water. Okay, so first this happens. This is number one. Then this equation happens, and then the hydroxide ions in the middle here are going to react with the hydrogen ions to form water. Okay, now, and then the water comes out here as a waste product. Okay, so the water eventually comes out as a waste product down there. So why does it keep happening then? Well, if this is a tiny bit above what you know already, but if we keep on removing the water, more H plus ions are going to go through and are going to go through. So if we remove things from one end, things will naturally keep on going into the other end. Okay, so that's how it works. So these hydrogen molecules lose electrons, okay, and the oxygen molecules gain the electrons, all right, to produce these, and then these react with these, the hydrogen ions, to produce water. Okay, and these keep disappearing because they keep reacting with the hydrogen ions, and therefore this reaction keeps taking place. Oxygen keeps on wanting electrons as you push more electrons in, and so the hydrogen will keep supplying them. So as long as you supply hydrogen at one side and oxygen at the other side, you'll get a flow of electrons from this side to this side. Okay, it is a confusing topic, I must admit. All right, but to make it a little bit easier, I've got a question for you. Okay, let's have a look here. There, oops, I can't do it like that anymore. Right, let's put something in. There we are. Okay, so this is a question on the fuel cell. This is exactly basically what I've just done. Fuel cell produces electrical energy by the oxidation of a fuel by oxygen. All right. The fuel is usually hydrogen, but methane and methanol are also used, as it says there. Diagram of a hydrogen fuel cell, which is the one we have to know about, is there. So hydrogen goes in, it loses its electrons. The electrons are picked up on this side by the oxygen, and we eventually get water. Okay, this is much more simple than the one I've done. Okay, but that's fine. It's ignoring some of the equations that go on, isn't it? For example, this one, where does the water come from? Okay, but it's the same in principle as we've done. Okay, and instead of having a light bulb here, it's got a voltmeter, so we can test how many volts we generate. When fuel is hydrogen, the only product is water. But when we use methane, what else are you going to get? Well, methane will get oxidized, and another product you'll get is carbon dioxide. Okay, let me write that down. Carbon dioxide. Write the equation for the chemical reaction that takes place in a hydrogen fuel cell. Right, now, the overall reaction, this is not a very good question, is it? But the overall reaction is this. Hydrogen ions react with hydroxide ions to form water. Okay, but a nice answer as well is, well, hydrogen reacts with oxygen to form water. Okay, because that's what's happening eventually, isn't it? We put hydrogen in, let me get a different color there. We put hydrogen in, we get oxygen in, okay, and we get water out. So the overall equation is this one. At which electrode does oxidation occur? Well, oxidation is the loss of electrons. Okay, is the loss. Which side loses electrons? At this side. It's at the hydrogen side. That's where they lose electrons. So, at which electrode? It's at the hydrogen electrode. All right. So let's do the rest of the question. Okay, there we are. All right, let's get rid of that. Right, an ionic equation for the reaction at this electrode. All right, well, we've done it already. Hydrogen. I don't know why I said two, though. You can say two, but let's get rid of the two. Hydrogen becomes 2 hydrogen ions plus 2 electrons. Yeah, and there you go. That's what happens there. Fuel cells are used to propel cars. Give 2 advantages of a fuel cell over gasoline. Well, obviously, one of the advantage is when we use a gasoline one, what do we get? We get water is the product of a fuel cell, isn't it? Sorry, I'm confusing myself here. So when we use a fuel cell, there's no pollution. Okay, because H2O is the only product. Okay, another advantage, fuel cells. Fuel cells are lightweight. Okay, they're lightweight. All right, they're quieter than a normal combustion engine. Okay, and they are a lot more efficient. A lot more efficient. Now, I've been looking at some numbers on this recently, and if you burn petrol in a car, for example, it's about 25% efficient. Okay. Now, what does the petrol do in a car? Well, obviously it moves the car along, but most of the energy goes into heating up the engine and getting rid of engine heat. All right, but fuel cells are getting close to like 99% efficient. There is some losses, but they're much more efficient, okay, than petrol cars. All right. Anyway, let me post this now. All right.